Stuck in a time warp, science fiction's favorite paradox. Imagine being trapped in a never-ending cycle of time. Each day, each moment, repeating itself endlessly. You are forced to relive the same day over and over again with no escape in sight. It repeats over and over, like a broken record stuck on the same track. This is the intriguing concept of a time loop, a phenomenon that has fascinated storytellers and audiences alike for generations. Time loops are a popular theme in science fiction. Movies like Groundhog Day, where the protagonist is caught in a loop of the same day, and Edge of Tomorrow, which combines action with the repetitive nature of time loops, bring this concept to life in vivid detail. But could time loops exist beyond the realm of fiction? Could they be more than just a narrative device? Physics offers some tantalizing possibilities. Theoretical physicists have long pondered the nature of time and its potential to loop back on itself. The idea of time loops challenges our understanding of reality, pushing the boundaries of what we believe to be possible. It makes us question the nature of time itself. Is it a linear progression from past to future? Or is it something more complex? Is time a straight line, moving inexorably forward? Or could it be a loop, twisting back on itself, creating endless cycles of repetition? Let's delve into the science and explore these fascinating questions. From the theories of relativity to the possibilities of quantum mechanics, the concept of time loops opens up a world of intriguing possibilities. Could we one day find ourselves caught in a time loop, or is it merely the stuff of science fiction? Join us as we journey through the mysteries of time and uncover the secrets of this captivating paradox. Decoding time loops, a journey through repetition. A time loop is a fascinating concept. It's a sequence of events that repeats. Imagine waking up to the same day. The same events unfold again and again. This repetition is the essence of a time loop. Time loops are often used in fiction to explore themes of growth and consequence. A character stuck in a time loop has the opportunity to learn from their mistakes. They may even strive to become a better version of themselves. But what does science say about the possibility of such temporal anomalies? Einstein's relativity bending time's era. Albert Einstein revolutionized our understanding of time. His theory of relativity proposed that time is not absolute. Instead, time is relative. It is affected by gravity and motion. Einstein's theory suggests that time can be stretched and compressed. This is called time dilation. For example, time moves slightly slower for objects in strong gravitational fields. This concept of time as a flexible entity opened up intriguing possibilities, including the theoretical potential for time travel and time loops. Closed, timelike curves paths to the past. Einstein's theories gave rise to the concept of closed, timelike curves, or CTCs. CTCs are theoretical paths through spacetime. These paths loop back on themselves. They potentially allow for travel through time. However, CTCs remain highly theoretical. Creating a CTC would require exotic matter with negative mass. This type of matter is not something we've ever observed. The existence of CTCs and their implications for time travel are still subjects of intense debate and speculation within the scientific community. Section 5. Wormholes, cosmic shortcuts through space and time. Wormholes are another theoretical phenomenon linked to time travel. Imagine a tunnel connecting two distant points in space-time. That's a wormhole in a nutshell. Theoretically, a wormhole could act as a shortcut. It could allow travel across vast distances or even through time itself. However, like CTCs, wormholes remain purely theoretical. We have no observational evidence to confirm their existence. The immense energy required to create and stabilize a wormhole presents another significant challenge. Section 6. Quantum quirks. Time travel on a tiny scale. Quantum mechanics, the physics of the very small, introduces its own set of time-bending possibilities. One such concept is retrocausality. This is the idea that an effect can precede its cause. While this might sound like time travel on a microscopic scale, it's important to note that retrocausality in quantum mechanics doesn't imply a violation of cause and effect in the macroscopic world. Whether such quantum phenomena could ever be scaled up to affect the flow of time on a human scale remains an open question. Section 7. Paradoxes of time travel, untangling the grandfather paradox. Time travel, especially the idea of time loops, often leads to logical paradoxes. These paradoxes challenge our understanding of time and causality, making us question the very fabric of reality. One of the most famous is the grandfather paradox. This paradox is a classic example that has puzzled scientists and philosophers for decades. Imagine you could travel back in time and prevent your grandparents from meeting. What happens to you? Would you cease to exist, or would the timeline somehow correct itself? You wouldn't exist to travel back in time in the first place. This creates a paradox where your very existence is called into question. These paradoxes highlight the complexities of time travel. They force us to confront the limitations of our current understanding and push the boundaries of theoretical physics. They raise questions about causality and the nature of reality itself. How can events be interconnected in such a way that changing one event could unravel the entire timeline? Some physicists believe that such paradoxes suggest time travel is impossible. They argue that the logical inconsistencies make it an unfeasible concept. Others propose that time travel might be possible within certain constraints, such as the Novikov self-consistency principle. This principle suggests that any actions taken by a time traveler were always part of history, thus avoiding paradoxes. According to this principle, the timeline would adjust itself to prevent any contradictions. For example, if you tried to prevent your grandparents from meeting, some other event would occur to ensure they still meet. Another theory is the multiverse theory, which suggests that each action creates a new parallel timeline. In this scenario, preventing your grandparents from meeting would create a new timeline where you never existed, while the original timeline remains unchanged. These theories offer fascinating possibilities, but also highlight the immense complexity and unknowns surrounding time travel. Whether time travel is possible or not, the grandfather paradox remains a captivating topic that continues to inspire scientific and philosophical debate. As we continue to explore the mysteries of time, the grandfather paradox serves as a reminder of the intricate and often perplexing nature of our universe. It challenges us to think beyond the conventional and to question the very essence of reality. Section 8. The Cyclic Universe, a cosmic time loop. Zooming out from our planet, some cosmological models propose the concept of a cyclic universe. Imagine a universe that expands and then contracts. This cycle repeats over and over. In this model, the Big Bang is not a singular event, it's a recurring phenomenon. Could this be considered a form of cosmic time loop? It's a fascinating thought. While the cyclic universe model is not currently the leading theory in cosmology, it does offer an intriguing perspective on the nature of time in the universe. Section 9. Time loops, fact or fiction? So, could time loops really exist? This question has intrigued scientists, philosophers, and science fiction writers for decades. The idea that time could bend back on itself, creating a loop where events could repeat or change, is both fascinating and perplexing. The short answer is, we don't know. Despite the numerous theories and speculations, concrete evidence remains elusive. The concept of time loops is still largely theoretical, residing in the realm of mathematical equations and thought experiments. Time loops remain a theoretical concept. They are often discussed in the context of general relativity and quantum mechanics, two pillars of modern physics that sometimes offer conflicting views on the nature of time and space. They are fascinating to explore but not currently supported by scientific evidence. Researchers continue to investigate the possibilities, but as of now, we have no empirical data to confirm the existence of time loops. While Einstein's theories of relativity allow for the possibility of time travel, they also present enormous challenges. According to these theories, time is not a constant. It can stretch and compress, influenced by gravity and speed. The creation of closed, timelike curves or stable wormholes would require exotic forms of matter and energy we haven't even discovered yet. These hypothetical constructs, often referred to as exotic matter, would need to possess negative energy density, something that has not been observed in nature. The paradoxes inherent in time travel, such as the grandfather paradox, further complicate the matter. If you could travel back in time and alter events, it raises questions about causality and the very fabric of reality. Would changing the past create an alternate timeline, or would it cause a paradox that disrupts the flow of time itself? While the cyclic universe theory offers a captivating vision of cosmic time loops, it remains a hypothetical model. This theory suggests that the universe undergoes endless cycles of expansion and contraction, potentially allowing for time loops on a cosmic scale. Understanding the true nature of time and whether it allows for loops, paradoxes, or journeys to the past remains one of the greatest unsolved mysteries in science. As we continue to explore the depths of theoretical physics and cosmology, we may one day uncover the secrets of time loops. Until then, they remain a tantalizing possibility, a blend of fact and fiction that fuels our imagination and drives scientific inquiry.